Welcome to this video on color measurement using a spectrophotometer. This technical guide explores color science, instrumentation, and quality control in the textile laboratory. Understanding color begins with the visible spectrum, spanning 400 to 700 nanometers. Color is defined by three attributes: hue, the color family; value, the lightness or darkness; and chroma, the strength or saturation. The CIE LAB color space is a three-dimensional model that mimics human visual perception. L represents lightness, while A and B represent color along the red-green and yellow-blue axes, respectively. The L star axis ranges from 0, black, to 100, controlling color depth. The A star axis moves from green to red, and the B star axis from blue to yellow. Monitoring these components helps control color variations. Delta E, or delta epsilon, is a single numerical value quantifying the total color difference between a standard and a sample. It's the critical criterion for shade matching in textiles. A low delta E indicates a better match, while a high delta E suggests a noticeable difference and risk of rejection. The standard CIE 76 formula calculates the total color difference based on the change in L star, A star, and B star values. This table provides a guide for interpreting delta E values for quality control. Values below 1.0 are generally considered acceptable. Over time, the delta E formula has evolved for higher accuracy. CIED 2000 is now the industry benchmark, providing the most perceptually uniform results and reducing false rejections, leading to improved buyer confidence. Metamerism occurs when colors match under one light but differ under others. Standard illuminants like D65, daylight, TL84, shop lighting, and A, incandescent bulb, are used to test for this. Always check critical shades under multiple light sources before approval. The spectrophotometer measures fabric reflectance across the visible spectrum. The working principle involves a light source activating, the fabric reflecting light, the detector capturing the signal, and software converting the data into LAB and delta E values. Key components include the light source, monochromator, measuring aperture, detector, and software. Measurement geometry is also crucial. D/8 geometry is recommended for textiles as it minimizes the effect of surface texture on readings. Aperture size varies based on fabric structure, small for fine fabrics and large for coarse ones. Standard illuminants like D65, TL84, A, tungsten, and F11 are used to detect metamerism. Always measure under multiple illuminants for reliable results. Standard observer settings include 2 degrees for small viewing and 10 degrees for larger areas. Applications in textile QC include incoming fabric checks, dyeing lot control, printing consistency, and final inspection for buyer submission. Be sure to align observer settings to avoid color value mismatch. Thank you for watching this guide on color measurement in the textile laboratory. We covered color science, delta E calculation and interpretation, metamerism, and spectrophotometer instrumentation and applications.